Hi guys, welcome to Learning Electronics Repair. I have this on my bench today. So this is an inverter, and the first thing it's doing is telling me not to repair it, okay? Do not open or disassemble the inverter. Attempting to service the unit yourself may result in the risk of electrical shock or fire. Okay, so hopefully I will survive this repair video. We will see. Or rather you will see, because if I don't, I won't really know about it. Yeah, okay. So this is a power inverter. Okay, DC to AC power inverter, AC outputs, and on the other end, DC input 12 volts. It's a 12 volt one, yeah. This is the model HT-P-2500-12, so 2500 watts, 12 volts. Okay, you can see. And there's a bit of a backstory to this. So Handy Andy brought me this in. This came from a thinker. Yeah, not a thinker, a thinker. What's a thinker? A thinker refers to a rural property or estate often located in the countryside, characterised by its traditional charm and connection to nature. Okay, that's what a thinker is. And this is a thinker, so you can see a little bit more clearly. This one is actually on Gran Canaria, although I doubt it's the one this came from. I mean, that would be extremely unlikely. Yeah, so this is a thinker, you can see. Sort of housing like this, okay. Yeah, basically middle of nowhere. And a lot of these places are off grid, so the only access they have to power is solar, okay, solar powered only. And Handy Andy tells me they have two of these and they've both packed up at the same time. I assume, I'm guessing they didn't have one sitting around dead for a while. They've both packed up and they've got no power, no lights, nothing. Okay, so can I fix it? Well, that will depend on what's wrong with it and if it needs parts. I've never tackled one of these before, but I guess it's much like a big switch mode type thing, really, or DC to AC converter. So let's have a look inside it and let's see what we can see. And then we can try and power this up from the bench supply. I'm wondering, because they've both packed in, whether there's nothing wrong with this or the other one and there's some other issue. Okay, we'll find out, I'm sure. Well, that was a good start. The head shielded off the bolt, okay. That was a good start. Try another one. Well, this one unscrews, that's a bit better, yeah. And this is what's inside it. A lot of dust and a plastic sheet. So let's get this off. Okay. Lots of capacitors. 1, 2, 3, 4, 5, 6 large inductors, some fuses. More capacitors on this side, okay. So clearly we have two different voltage levels. Those are different size capacitors. I think they're capacitors. These could be inductors, actually. Just look at them, not sure. Okay, a lot of transistors or MOSFETs. Probably MOSFETs, we'll see. A lot more of them over this side, different type, different size. Yeah, okay, and quite a bit of dust. So I'll just get a brush and brush that out. I mean, it's Gran Canaria, what you expect, of course, it's full of dust. I had a quick look for schematics, don't seem to find anything. Okay. I did find a user manual. So it tells us what the light should do, at least how it should behave. And a troubleshooting guide. Yeah. No output voltage, make sure the battery's connected. No voltage indicator, internal fuse blown, change. Inverter shuts down and overload light shows. Reduce the load or overload. Inverter shuts down over temperature light, shows, improve the ventilation or let it cool down, and low battery alarm, change the battery. Very little maintenance is required, and that's about it. Okay, so first thing will be fuses. We have, I can see here, 4 fuses. There's 4 underneath here, and there's another 4 there. And you see we have 2 red wires coming to these 4 fuses, 2 to those, 2 to those. So it's fairly obvious to me that we have 1, 2, 3 inverters, or maybe 6, and there's a pair for each. So there's either 2 transformers per inverter or 6 inverters here. This lot is, well, this looks like firmware or some sort of MCU. Okay. Some sort of IC1, probably a voltage regulator, that actually. Resistor, some sort of drive circuitry or something like that, or monitoring circuitry. Those are capacitors over there. Okay. And then down this side, low value resistor, more resistors, some sort of chip here. TL, something or other. Oh, that's almost like one of the chips he put on the ATX. I think this will be the oscillator. Yeah. Some transistors, probably drivers. So I'd say this lot here are the drivers which drive these transformers. And we can be pretty sure of that because on the other side we have a connection here to the mains out. Okay, so this is your mains coming out this side. That's your 12 volts going in that side. This looks like there might be some sort of standby supply or small supply which powers the control circuitry. Looks rather like, I can see some diodes down there in the capacitor. Yeah, and the voltage regulator, I would think. So that probably powers up all this lot, and certainly this lot, okay. So first thing then would be the fuses. Let's look at these fuses. So just go to continuity. Yeah. What do we have? Well, that reads like a voltage. You know, that tells me there's some voltage in this somewhere. The fact it's not reading continuity. Let's go to volts. Yeah, look, there's a voltage across the fuse. The fuse must be open. Not on that one though. So does that one read like properly with the resistance? No, there is a voltage across there, just didn't have a good connection on it. Yeah, look. So there's about 2 point something volts across these. So that must be charging these capacitors on this side here. Let's look across the input terminals. What do we have? 4.5 volts. So it looks to me like these capacitors have charged up and they're holding a charge, and the reason they're holding a charge is because there's no load to discharge them. And why there's no load, I'm probably going to say now, all the fuses have blown. Yeah. Let's discharge this. So I'm just going to use a resistor. Yeah, these are 10 ohm resistors, so 5 volts, 10 ohms, half an amp maximum. Let's just see if we can discharge all this lot. Okay, what do we have now? Yeah, it's a lot less. I'll just short that out then. Okay, so just short out that input. Let's see if we can get rid of the voltage, and then we'll try these fuses again. Okay, so yeah, it's pretty much gone. Can I measure them now? Yeah, it reads open circuit. These read open circuit. Let's take all the fuses out and see if they've just failed or if they exploded. Yeah. Okay, I've taken that other bracket off. I'll just check these as well. I'm pretty sure they'll all be open because of the fact we had that voltage in the capacitors. Yeah. Now that reads Okay. That one appears to read okay. Okay, what about these actually? So these ones seem to be reading open. I don't know why, guys, but now these look okay. Go figure that one out. Same with that one. So it looks like I have some good fuses and some bad fuses. Or probably just bad connections getting onto them actually with the probes. I'll take them all out and just check them to be sure. So all the fuses are out and we have some problems here. I'll show you. I also spotted now down here 3 more glass fuses. They were sort of under these wires, so let's just check these. That one's okay. That one's also okay. And that one's also okay. So they're all okay. These fuses must be on the input side of this because the high current, the 25 amp each. Obviously, whatever the current is on the load at 240 volts, they said it was 2500. So about 10 amps. Okay, this can provide. At 12 volts, it's going to be 20 times as much. Okay, so that's why we have all these high wattage fuses. 100. Roughly 300 amps worth. So 300 times 12 is, well, 3600. That kind of makes sense. So for 2500 watts out, it's not 100% efficient. 3600 watts in, yeah, that all makes sense. So some of these fuses are gone. I've numbered them. Let's have a look at them all under the microscope. I think it's reasonable to assume I have 6 transformers, 12 fuses, so 2 per transformer. That one is clearly gone. Yeah, burnt through, you can see it in there, so that's gone. This one is either gone or it's distressed. I think it's actually gone. This one actually came apart when I actually unplugged it. This was kind of like welded itself into the socket, so I actually broke it as well. But I'd say that was already gone. So that's the first transformer. Second transformer, that is clearly good. And number 4, there's obviously been doing some work. You know, I'd say it's okay. It's just been working hard. We could just check that. That's okay, but distressed. 5 and 6. Well, again, that's obviously been working hard, and this one again has welded itself in. It wasn't gone, it's just obviously just bent the fuse. You can see it okay, but that was actually okay. 7 is gone. And 8 is gone. Yeah, so that's another transformer. 9 and 10, well, it's obviously been working hard, but they're okay. And 11 and 12. Well, that one again has been working hard, maybe gone actually, and that one looks like it's, yeah, that's gone. So what I have, if it's laid out as I think it is, with 2 fuses per transformer, this channel, the fuses were gone. These 2 are okay. That one was gone. That one was okay, and that one was gone. So 3 channels down. 3 phases, if you want to call them that, yeah. Okay, so, although it's not 3 phase, by the way. So maybe we won't, yeah. But we have 3 of these down. So, the question is why? Well, I've taken all the fuses out, all of them. How many of these power devices do we have? 24, that's a nice number again, isn't it? 24 of those with 12 fuses. Okay, so again, I think we can say there's 4 of those per transformer. Makes some sense to me. Let's have a quick look at these. Well, I don't see any short. Okay, I'm not sure what the devices are at the moment, but that one I saw a reading. This one I don't. So this one there's definitely something different on that one. Okay, I think what I need to do now is actually take this board out so we can see what devices we have, how they connect up, and then see what else is faulty from that. Yeah, okay, we have it. So let's see what we've got here. Looks like I could probably take this heatsink off with these screws. I'm not sure if I can actually get these individual clips to come out. They seem to be like kind of pushed in there basically. Let's just try one. I mean, obviously the whole thing would come off. Let's see, do these things spring out? Yeah, they do. Well, that makes it a bit easier. Yeah, sorry it was off shot, but they come off quite easily. So I'll just take a couple off to see if these are the same devices at the end here. Okay. Yeah, what are these things? CEP9060, okay. MOSFETs, as we would expect, N-channel MOSFETs. 55 volt, 100 amp, 300 amp pulsed, okay, so MOSFETs. Let's see how they're connected up. So, yeah, we have one pin on all of them all connected together here, which looks like the, well, it's the end pin, whatever it is. You would think that would be the source, but maybe this is the drain. Maybe, actually, no, this is the negative end. So, look, these are the black terminals all here. Okay. They come in here. They connected to that. So this is the, well, the negatives go. Yeah, that goes to here. I thought it would. So that will be the source on each of these MOSFETs. And that effectively is on the low side. So we're going to have the 12 volts coming in via the transformer coil into the MOSFET. Okay, that's how it looks to me. And then we can see they're in pairs. Yeah, from the drain they're all in pairs. So this ties in with what I was saying about the transformers. The transformer is here. Okay, the first one. We can see both ends of the transformer here and here. I wouldn't be surprised as there as well. I'll bet these are driving either end of that coil. So this goes down to here. This goes to here. Well, we'll see a short obviously because of the coil. And then we have another pin on it here which goes to this thing. And they are the fuses. Okay, so yeah, this is starting to make sense. What we have is we have a center tap primary. So one end of the center tap via the fuses will go, I would say. Fuses probably come to, let's see, where are they? They're in that area, so here. Yeah, so this is effectively the center tap. This is where the fuses are, and then that's where the 2 red wires go. So one red wire feeds this pair, another red wire feeds this pair, and so on all the way down effectively, okay. And each pair is set through its own fuse, makes sense. So that is the positive, and then what's happening here, these MOSFETs are switching and turning, grounding either one end or the other of the primary, and that's why we get the alternating signal, okay. I'll draw that for you just in case you're a bit confused. Yes, so what I see is plus 12 volts coming in, and there's 6 of these circuits. Okay, so the 12 volts comes in to a center tap on the transformer primary, like so. Okay, and then from the other end, let's draw it this way, we have on here a pair of MOSFETs. Okay, and on here we have another pair of MOSFETs. Okay, like this. Obviously they have gates, but we're not worrying too much about that at the moment. So the MOSFETs all connect like this, and this point is ground. So 12 volts in, 2 MOSFETs, ground, and you can switch this pair on and this pair on. Okay, and so the current is going backwards and forwards. And in here, because I didn't draw it, so I better do, we actually have a pair of fuses, like so. Okay, so this will be 50 amps, pair of fuses, and we know that fuses have blown on 3 of the transformers. Okay, what we need to do now is look for shorts on these MOSFETs. So we're going to check all the MOSFETs. I'll just make a note on the PCB of which of the 3 transformers were actually the ones which had the blown fuses, because I'm pretty sure the thing will relate to where the fault is. Yeah, well, I've marked them here. So I'd already made a mark on the heatsink. I knew where the problem was, there, and there. I'm not playing noughts and crosses really. So X means the fuse was blown. They were okay, they were okay, they were blown, okay, blown. So we should be able to see effectively a difference. I know all the sources connect together, but the drains, like these are in parallel, these are in parallel, and so on. So what can we see with the meter? Well, I'll start in ohms range originally. So negative here, because this is the negative end of the circuit anyway. 2.6 meg, that's high. That's high. That reads open, so there's a definite difference. Yeah, we can see a difference. This reads open, this reads open, this reads open. Well, that suggests some voltage somewhere, something charged. Open, open. 7.8 meg, 7.8 meg. I mean, we can't have negative resistances, but we can have a bit of voltage in the capacitor somewhere. What's it reading now? It's climbing up. Again, we see a resistance, we see a resistance. Okay, so it looks like, in fact we know there's definitely a fault on 3 of the drivers. Yeah, we could have a fault on the output as well, but let's just concentrate on this side of it first. Okay, I've switched the vacuum desoldering tool on. Now these could be a bit tricky to get out. I'm going to take the 4 MOSFETs out on this one first. I'm not going to worry about the others, and see whether with them out, A, I can test the MOSFETs, and B, does that reading go away? Yeah, that strange resistance reading. So just these 4 first. This could be a bit tricky because, well, you can see the size of these power planes, yeah, and ground planes. I think what we'll do is we'll add some leaded solder. I'm going to just warm this thing up a bit with the hot air to get some heat into these tracks, and it's going to be easier. Easier, didn't say easy. Okay, it's going to be easier to get these things unsoldered. So that should be quite warm now. Some nice thick solder. This is 1.2mm, very thick. Let's see. Well, now you see I still can't solder to the thing because it's not hot enough. The metalwork isn't hot enough. We'll add some flux. Always helps. A bit more heat. Let's try. Let's see if we can unsolder these. Maybe. Maybe. A bit more soldering. May need some hot air at the same time actually on this one. Better. Well, let's see if these will actually come out. Yeah. That was a little bit stiffer, this one. A little bit more heat on that one. Yeah, that one came out. I can see which pin it is. Yeah. Other one. Again, same pin. Okay. Okay, let's see if that strange reading has gone away. My X certainly went away, so to speak. Yeah, what do we have? We certainly has to have something here. Okay, so there's something else as well. It's not, either it isn't them or it's not just them. Yeah. Let's look at these MOSFETs. Okay. Yeah, that's fine. 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 Okay, so it's not the MOSFETs for sure. Well, what else would be in circuit in that point? Yeah. What else would be across there? I can't really, for the moment, just imagine or picture what there would be, but obviously something is. I mean, those tracks go down here. So there's something there. That's just a transformer. Okay, that's just a transformer. So there's nothing else here but the transformer. Yeah, you can see that there's nothing else connected on this track or this track but the MOSFETs, which are now removed, and the transformer. So that suggests that I'm reading something back through the transformer, and it must be back through here. But this will just read short because of the transformer. These fuses are removed. Now the fuses are out, so it can't be there. That's where the fuses are, you can see them. So I'm down to the transformer. I mean, there's nothing else on here. Yeah, there's nothing else on here. And yet to ground from here, I see, it's in the mega ohms, fair enough, but I see something, and from here I don't, and I see the same problem on all the bad ones. Different resistance, okay, through the mega ohms again. So if I measure from the secondary to the primary, I see this will be the same, but I see open basically. Okay, so this puzzled me at first, but I've sort of figured out what must be going on now. We can see that this goes to the primary, that's the centre tap, that's the end of the primary. The MOSFETs are removed, so there's no connection from here to there, okay? And the centre tap goes to the fuses here, and the fuse is removed, so there's no connection there, but there is something else. So we have a resistor here. It's a 10 ohm resistor, and we have another one on the other side here, 10 ohm resistor. So whatever I'm reading to ground must be coming through that 10 ohm resistor. So it's whatever's the other side of there has some resistance to ground. Unfortunately, because this resistance I'm seeing is so high, 1.735, I can't say, I mean, the other side of the 10 ohms is just going to look the same, yeah, but wherever that 10 ohms goes must be where I'm seeing that resistance. Now, where might that go? So there's one per pair of these. It must go into the drive circuit somewhere. Does it go to the gate? So this is the gate. So this has another, that's 10 ohm as well. Yeah, these are all 10 ohm. These are the gate resistors. So one end of these connected to this. No, just see that high resistance compared with another channel. I see nothing. Okay, so this is clearly where this is. I wonder if it's something to do with the chip that's driving these, which is the fault. So we see it to there as well. Okay, how about from here to here? Well, they are short, so those ends are actually connected to each other, but that's all this metalwork. From here to here, yeah, 20 ohms, that's the two resistors, okay. So the problem is effectively from here to here, this is open. This is the resistance, so I need to figure out where they go. And I think they must go to whatever's driving these MOSFETs. And that, I would assume, is probably going to be these. 1, 2, 3, 4, 5. There's 8 of them, so it doesn't kind of match quite what we'd expect. And there's a chip there. Okay, let's look at the data sheet for this thing. TL594CN. Pulse width modulation control circuit. Yeah, what I thought it would be. This is very similar to the ones we find in switch mode power supplies in actual fact. So this basically has two outputs that switch alternately. That ties in very much with switching both ends of this transformer, and it looks like that one chip drives all of them. But in between are probably these transistors. I'm guessing these are probably going to be complementary pairs, NP, 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 just a guess. PN2222. No, maybe not, they're the same. Oh. 2222. 2907. No, 2907. I couldn't read the number. Yeah, complementary pairs. I'm certain of that. So 10 ohm here. Yeah. Go to these things. Not that one. Okay. No. So not to those. That will come on the resist on the good channel. So this one. Well, this reads open again to here. You see that? Reads the resistance to that one. You can see the middle pins are connected to each other. So that reads the resistance to that one. One of them is somewhere on here. Actually, I don't see it now. No, so they don't seem to go there, but this one sees these funny resistances again. This is our chip. Let's see if we've got some connection from here to here. Well, this chip must control all of them, I mean, to be honest. From here. No, again, we're reading this open, so there's clearly something where this goes to that is different. Okay, I think we can narrow this down a bit. So we have the two resistors. Okay, one here and one here. And these two ends don't connect to each other. Okay, we read 20 ohms from here. So the reading back through on those ends effectively connect to each other. And we can see that. So these ends connect to the same place. Yeah, these ends don't. We're just reading through one and back through the other. This one is actually under the edge of the transformer. I can't even get to it. I can get to this one. So if we lift one end of this one, okay, and we see where we, or if we're still reading that strange high resistance. Okay, let's try it and see if this helps to pin it down. So I've just got the tweezers stuck under that edge of that one. It might actually break when I try to get this out, but it's a 10 ohm resistor. I can easily change it, not really a problem. Let's see if I can actually persuade this to lift out. Just try and get a good angle to work on. Okay, so just heat this up. Yeah, it's come out. You can see there I've lifted one end of the resistor. Now, where do we see this resistance? Do we still have it? Yes. How about from here? No, we don't have it from here. So it's obviously we're seeing that through this other resistor. We need to figure out where that goes to. Okay, it's definitely coming through this one, not through this one. And we know on the good channels we don't see it at all. So we need to figure out where that resistor goes. Okay guys, so I've unsoldered this one. So we can see from here to here reads open now, okay? The other one I can't remove, it's underneath the transformer, yeah? But I've unsoldered this, so this is loose, okay? And this also reads open, okay? So I'm not reading down that way. But I still see this 1 meg reading from here. And I think I've disconnected everything. Just go to see this one's open. The other ones, well, that reads open now. Yeah, they read open now. There. Just on this one. Let's go to diode mode. So what do we see? Well, that's climbing up. See where it stops. Well, I'm obviously charging capacitors, but bear in mind this here is the plus 12 volts and this is the ground. So you can expect there to be capacitors across there. And it eventually goes to open. How about this one? I'd say this goes to the same thing. Yeah, so they both go to open. Obviously it's just discharged a little bit. Let's just go on again. We'll go back to open. So I'm wondering if that I'm reading is really a bit of like a red herring. I think what we'll do with this one, I'll solder these resistors back in. I'm going to put this back together. I'll put some fuses in it. I'm going to power it up from my bench power supply, which I have a current limit on anyway, with no load. And let's see what it actually does. There could be some problem on this end of it, the high voltage end. But A couple of things make me think maybe not. One, that the fuses have not blown. The fuses are intact here. It was just some of these that are blown, not all of these. I don't know what all these things are doing. I'm going to have a look at one of these because I can't really imagine why we would have all these devices on the output. It's supposed to be AC. So I can't see there being diodes, and I can't imagine what else they would be. Okay, so let's put this back together and let's just try it. I don't think anything much can go wrong, especially if I set some sort of current limit on the power supply. I've put those components back in, and I've had a bit of a look at this. I know a bit more about it now, so I'm going to show you what these devices are here, and then I'm going to explain how I think this actually works. So these are diodes, double diodes, you can see there, yeah? A whole row of them. You can see which ones they are because you can see the first part of the logo on them, okay? And you can also see where they connect here. So 1, 2, 3, 4, 5, I think 6 or 7. 8. There you go. Okay. So there's 8 of them there. So these will give you a high voltage DC output. And right behind there are these capacitors I mentioned. I said, well, what are these? So looking at one there, we can see 400 volt. Can't quite see the value of the capacitance, but high voltage capacitors. And they are all in parallel. So some of this makes more sense now. These transformers are like switch mode transformers. They're not like mains transformers, which you find in small inverters. So all this lot must run at high frequency. That chip we know is typically used in ATX type power supplies, so runs at high frequency. These transistors track them through, and they actually drive the gates of these, okay? So this is a switch mode power supply, effectively not an inverter, mains frequency, and it's converting all the rectifier diodes to DC. So this is a high voltage DC power supply. Here we have, well, best part of 400 volts DC, I guess. From there, then, we have all these. So these are MOSFETs. IFPFZHDO. Again, I haven't taken all the clips off, but there's a lot of them. These ones seem to be in parallel with each other, and then these in parallel with each other. So 2 sets of them. And this, I think, is then chopping up that high voltage at 50 Hertz. Yeah, I think this is what generates the 50 Hertz AC, this part of the circuit. Yeah. I'm not quite sure where the controller is. This is a LM393, so some sort of comparator. The other one, LM358, dual op amp. So that's what we have, but that's how this is working from what I see. There is a chip here. Maybe this is actually controlling that lot. I don't really see anything much else, so probably so. I'm going to put it back together now, and then let's power it up and see what it actually does or doesn't do. I've connected this up to my bench power supply, so this will go up to 10 amps. I've set the current limit at 5 amps. I think I need to get some power in this to charge up all these capacitors anyway. Let's just switch it on and see what happens. And it's drawing no power at all. So let's switch this on here and see what it does. Well, it bleeps and it's saying something like LUP, which is low power, I think. I'll have to check what that was meaning in the instruction manual. Let's just go again. So bleep. This time it's on. And just say 11.7. So it's actually powering up. If we stick this up to 10 amps, and we'll try connect a light bulb, just like a 60 watt bulb or something, and see what it does then. Okay, so this is a 72 watt halogen light bulb. Yeah, have my bench power supply there. Let's switch this on again and let's see what happens. So boot, bulb's on. Okay, 116 or something it's saying. This is saying 113. Clearly this does work. It isn't exactly repaired yet, and the reason being that I don't have the correct fuses. So these are some of the 25 amps. I've got some 15 amps and 20 amps. I think we have a bit of a mixture here. I didn't have any 25 amps, but because I'm only drawing low power, I can put those in for now. And we can clearly see it works. So I just need now to go and buy some of the correct fuses. This can go back to the customer. I suspect what's happened here is that they've been overdriving this. They're drawing too much power from it. I'm going to tell him this. So we know some of the fuses look distressed, some had blown, and obviously that stopped the thing from working. They need to run less load. They have two of these. If they've got such a high load, they need to have a third one. That's my opinion of it. He says there's another one for repair, so we should have that one here. Maybe it's just the same problem, I don't know. But we can say this one, well, I'm not sure exactly it was repaired. Yes, it was. Replace the fuses, it's repaired. I think it was more interesting because now hopefully we all have a very good idea of the topology of this thing, how it actually works, which is not exactly how I expected it to work. And let's face it, when we see another one, what we know is going to help us. Okay guys, I hope you really enjoyed that, and I look forward to seeing you all soon on Learning Electronics Repair. Ciao for now.